Hi, good morning, good afternoon, good evening, wherever you are. Welcome to our panel, Ask Me Anything About Service Mesh. Let me quickly introduce myself. My name is Linsa. I'm a senior technical staff member at IBM. I'm also an Istio contributor. Today we have exciting panelists. I'll let them introduce themselves. Dan?
Hello, everyone. I'm Dan Berg. I'm a distinguished engineer at IBM, primarily focusing on our Kubernetes service, as well as introducing and delivering service mesh capabilities into IBM Cloud.
Great. Sven, can you go next?
Sure. So I'm Sven Mawson. I'm a senior staff software engineer at Google. I'm one of the founders of the Istio project with Lynn and Dan. I work on the technical oversight committee and steering committee with both of them as well. And I've been interested in how service meshes can help solve problems for developers for years. So very excited to be here.
Awesome. Thank you. Christian?
Yep. Hopefully you can hear me. It's good to see you. My name is Christian Posta. I'm a field CTO at a company called Solo.io, where we focus on helping customers use service mesh in production and kind of meet them where they are, figure out what their challenges are, and help them to be successful. And we have a few products that we've built to help do that. And I've been involved in building distributed systems and an open source for quite a long time.
Great. Thanks. Oliver?
Hi, I'm Oliver Gould. I'm the creator of Linkerd and the co-founder and CTO of a company called Buoyant. I've been working on service mesh since at least 2015 when we started working on Linkerd, and before that at Twitter and other places.
That's awesome. Thank you, everyone. Let's go ahead start with some of our questions. So we have a few initial seeding questions. We're going to go through those first. In the meanwhile, for all the audience, please go ahead and type your questions, and I will prioritize them after we've gone through our initial questions and read out for our panelists to answer them. So, the first question is, can you describe what exactly is service mesh? Let's start with Sven.
Sure. So to me, a service mesh is really about a way to decouple operations from development. So what I mean by that is sort of historically, you've had to build all of these kind of capabilities for managing multiple services all interconnected together into your applications. So you have to build, routing and observability and security and all these other pieces in with code. And that was kind of the historical view. And what service meshes do is they come in and provide that as an infrastructure layer. So you get all those capabilities without having to make changes to those applications. And then you can sort of decouple that operations from that development. And you can push changes rapidly. So you can reroute traffic, or add alerts on things and do all kinds of changes without having to go and change your code.
Awesome. Any other panelists wants to add anything?
Yeah, I mean,
I would be happy to. Go ahead, Dan.
No, you go, Christian.
All I was going to say is, for developers and enterprise users who already have experience with things like an enterprise service bus, API management, and so forth, it's, in my connected it's the evolution of that, just like cloud and containers and Kubernetes were the evolution of our infrastructure. And it fits the model better by decentralizing the enforcement points, by providing an API to enable automation. But it is about connecting applications and solving things like security and routing, like Sven said.
Dan?
Yeah, I was just going to add, all these points are absolutely correct. The one thing I was going to add, which is similar to what Christian was saying, is that a mesh is really the ability to programmatically define your policies and rules at the networking level. And I think that's a key aspect here, is that you can actually start programming these rules as opposed to codifying them directly into your application.
And I'll just add a little twist on all these, which, I mean, all these are right, but I view service mesh as really a pattern, right? And it's a pattern for extracting a bunch of the kind of connectivity and communication reliability logic out of the application. And you can have service meshes that are really good at security, or service meshes that are really good at observability or policy. But really what we're talking about is a pattern of having sidecar proxies or rich data planes that are programmable.
Awesome. Let's go to our next question. What are some challenges in adopting a service mesh? Oliver, can you start answer this first?
Sure. Yeah. So as we were just talking about, service meshes can do lots of different things, and there's lots of value that your organization may get out of a service mesh. And what we see frequently as folks try to adopt service meshes, they try to adopt all of the value at once. They want tracing and monitoring and retries and circuit breaking and all in policy, and they want to just deploy this all in one big fell swoop, and that makes it really hard and complex for organizations to adopt. And so our advice is to be really incremental, start with things like MTLS and load balancing and the kind of table stakes, and then grow the set of problems you're solving with the organization rather than trying to layer in a lot of things at once.
Anyone wants to add anything?
Yeah, I mean, so what we see with our customers is exactly what Oliver said, because it's both the capabilities. Like some service meshes have a lot that it can do, so that creates some complexity, but that also creates a people problem. What part of the organizations which already have these silos need to be involved, and if it's all of them, then that makes things a lot more difficult. So that is a big challenge. Another one is that the idea that the service mesh is just transparent and you just put it in your applications and it just works. But what we've seen is these applications aren't exactly cloud friendly. And they don't, there are gotchas, and there's not the transparency that they expect, and so there's some hurdles in adopting it in an existing organization.
I'll add one thing. One challenge we've actually seen in a lot of companies is actually that they have a lot of this stuff in a rudimentary form in their own home-brewed way. So a lot of companies have something like a service mesh. Maybe it's through libraries, maybe it's through some proxies, maybe it's a combination. And I think one of the big challenges is migrating from that state of your own custom stuff that kind of does some things well and some things specific to your organization, but not everything, and migrating to one of the standard service meshes. That's actually a pretty big challenge. Is how do you move that functionality over, and how do you have kind of both running at once? And that gets very, very complicated.
Yeah, interesting perspective. In the interest of time, let's moving on to our third question. How can users decide if they need service mesh or not? Dan, I'm going to pick on you to answer that first.
Yeah, that's actually a good question. If they don't know if they need to use a service mesh or not, they probably don't. And the first thing I would say is don't use a service mesh unless you know that you have a need for it. Fundamentally, though, folks that need a service mesh, ultimately they come down to a set of criteria. Some of it is that they already have existing code and they don't have a good view of either an understanding of how their services communicate, or they just don't have a very good security model to ensure secure communication across those services. or they just have a difficulty in managing rollout of new releases, new changes. And I did state that it's existing. It doesn't have to be existing, but the reason why existing is an interesting case is because you can adopt a service mesh, apply these at the networking level without modifying your applications. But again, I wouldn't just jump into a service mesh because it's the latest, greatest, shiny toy. You do need to look at what are the problems you're trying to solve, and does the service mesh actually fit those needs?
I have another opinion on that. So I think anyone needs a service mesh who has pod-to-pod communication that they care about. And that is, it's production traffic between instances running your Kubernetes cluster. I definitely agree that you should be really aware of what value you're getting into that. But I think things like MTLS and load balancing are kind of table stakes. And just in the way that you'd expect a browser to require TLS today, a service mesh can be doing that, connectivity between clusters securely. And that's important.
Yeah, and I want to really quickly generalize that a little bit more. I think it's not just for pods, right? Anytime you have lots of different services talking to each other, whether they're Kubernetes pods or VMs or mobile apps or IoT, right? Like that's where service meshes can be useful. And we don't all solve all those use cases yet, but actually it really is when you have that sort of lots of things communicating with each other. And I really liked what Dan said. I think we want to make sure people don't think if you don't think you need a service mesh, you don't need one. It's really, if you have the problems service mesh is trying to solve, you need one, right? So it's look at the problem space, and if there are things that service meshes are solving, that observability, security, and traffic routing and rollout and all those other problems. If you have those problems, right, service mesh is useful. If you don't have those problems, then yeah, you probably just have a monolithic application in your phone.
No one should want a service mesh. People forget other things.
Okay, great. Let's go through our questions. I actually saw a lot of questions coming in, so bear with us if before we get to your turn. Also, some of you are asking what Slack channels we're using. We're going to announce that at the end, just because we want all the questions come through this platform for now, and then at the end we're going to take questions on Slack. Here's a question from Rule. How should a service mesh be interconnected with an API gateway? An API gateway serving each mesh ingress gateway, or a central API gateway serving multiple clusters? Christian, could you take that first?
This is definitely an area of our expertise at Solo. Because like I said, we meet people where they are, right? And some people are able to adopt service mesh today, and some people are not. And the API gateway pattern is something that is familiar with folks. And as they start to modernize, they want technology that fits better with the GitOps model, that's declarative, that's very flexible and extensible, and so forth. So an API gateway in general is going to be different than a service mesh, and then it solves those application problems, getting access to applications and APIs at the edge of your boundary. And so we've seen people deploy, for example, our API gateway that's built on Envoy, glue at the edge of multiple clusters and then federate them, right? But we've also seen, and this seems to be a more prevailing pattern now, that folks are going to put glue or put their API gateways into centralized clusters and then route those to the leaf clusters, which would have the service mesh, and then maybe using something like a simpler ingress on those clusters. So we've seen both. Folks who have an aversion to centralization are going the federated model. Folks who already have their processes and their familiarity with the centralized model are going down that path. So it's just, there's not a right or wrong answer for that.
And we've even seen people doing both, right? They have like a centralized gateway that does some functionality, and then that is routing to sort of within each cluster gateways that then route to the actual application. So you can have multiple layers in there too.
Yep.
Okay, great. Sorry, there's no way I can actually check if the answer was satisfactory. So in the interest of time, we're going to move on. The next question. Oh, good.
Of course it was. I mean, come on.
The next question is from Guy Kobis. What are the criteria consideration that I need to take when selecting service mesh implementations? Certainly, he highlighted a few ones: Istio, QMA, OSM, and there's more Linkd. I'm going to, Oliver, could you try answer that first?
Yeah, you should use Linkd. Easy. No, I think, how do you choose any software, right? You look at the community that's around it, and you look at the kind of use cases that it excels at. Linkd, our goal is to make it easy to install and get out of your way. So I don't think people should want a service mesh. You should be able to install Linkd, get MTLS, get load balancing, get visibility, and then move on with your life. But certainly I think the other service meshes have lots of value that they can speak to more.
Yeah, I mean, I definitely agree with you. It's like any software. I mean, once you've done your initial investigation and narrowed the field down to, let's say, 3 options, you're going to have to take them for a test drive, right? Put them through the paces, test your use cases, test to make sure that it fits your operations and development style. At the end of the day, you have to evaluate, and you have to be comfortable with the technology. It's hard to say is one better than the other. The one that's the best for you is the one that works the best for you. So you got to give it a try, just like you would with a car. You're not going to go buy a car without test driving it. Why would you do the same with software?
Okay, good answer. Go ahead, Sven.
I was going to add that just to add one little extra piece, I would definitely agree with actually everything Dan Oliver said. The piece I would add is that I would recommend looking at service meshes that have actual production users, and maybe favor using ones that have a community around them, have production users, and have sort of a track record of actually being deployed in production and used at scale. Because as we've discovered, it's really easy to launch something that sort of ticks all the boxes, right? Like we launched Istio, 0.1, I don't remember how many years ago, and it had basically all the functionality Istio has today. And the intervening years has been spent making it scale, making it production ready, and making it actually able to meet customer needs at scale in production in real usage. And I think, people underestimate how difficult that is and how much time is spent on making something production ready rather than just, it does all the features that you need. So yes, try it out, use it.
That is incredibly, absolutely important. I mean, I assume people are, and we work with, like I said, we work with folks who are going through these evaluations right now, and they come to that conclusion. But from the outset, I mean, there's a new service mesh released every week, right? And you can see it, like Sven said, through Istio, and even look at AWS App Mesh. They announced almost 2 years ago, but my opinion is they're just now becoming ready to be used. And same thing with the Linkd. It's been around. They learned a lot. They pivoted. They got Linkd 2, and there are probably a lot of people running it in production. Those are real service meshes that usually bubble to the top of an evaluation criteria that we've seen.
Yeah, these are really good additions. I'm so glad you guys add them. You definitely want to drive a car that's stable and can survive on the highways for a long time. Let's moving on to our next question. I I think this is we from Girish. We have services across regions and across cluster. We want to try multi-cluster Istio feature. We need to specify service entry to talk to service across cluster. Can this be done at scale as we have a lot of services? Dan or Sven, can one of you maybe take this?
Happy.
Sure, I can jump in since I
go for it.
Okay.
Go for it.
Or do you want me to do, Dan?
Yeah, go for it.
I've been doing a lot of work on multi-cluster so this is actually so this can be done at scale. I think most people that are doing this at scale are using their own controller to write those service entries. That's something we actually are looking at right now, and we're working with also the Kubernetes community on a project called MultiCluster Services to define, how services get shared across multiple clusters in a more scalable way than each company having to write their own service entry controller. So right now it's doable. If you have tons of services, you should write a controller that is basically copying those everywhere and configuring them, because Istio doesn't do that out of the box today. But once that is done, it does scale and does handle the traffic. But we are
don't write your own controller. Don't write your own controller.
Well,
we have a project at Solo called Service Mesh Hub that does exactly that for you, and does other things in terms of federation. So there's an Admiral from the Intuit folks. So there's some things to look at for that.
Yeah. Also note that Linkerd 2.8 added a service mirror component, which basically is a controller that syncs services across clusters and lets you use traffic split between them.
Wow. Lots of things to explore in this space. Okay, let's moving on to the next question. I think this question is really, really interesting. I want to know the answer too. Service mesh are super flexible, but what you would not recommend to do with service meshes?
Business logic. Don't do business logic in service meshes.
Yeah, that's actually a really good, that's a great answer.
Yeah.
If you're looking at extending a service mesh, most service mesh allows you to do extensions in some fashion. If you find yourself doing business level applications as an extension to the mesh, you're probably doing something wrong.
That's going to be a slippery slope.
I know. Once you get into, once you find that hook, you can use it for all kinds of bad behavior.
Like, so for example, WebAssembly is coming to Envoy.
Yeah.
That's going to be a slippery slope.
So what do you think they shouldn't use the service mesh for then? They've taken it too far.
So is the question like, when have they taken it too far?
Yeah, they've done too much. They are trying to make service mesh solve a problem that it wasn't intended to do, and it doesn't fit well.
Yeah, no, I completely agree with the business logic thing, right? Because I mean, you can write your own services. You know, don't even have to.
I think we lost your audio, Christian.
Oh, did you?
Oh, you're back.
Yeah, back now. We lost maybe 15 seconds.
Oh, okay. Yeah, no, all I was saying is I agree with the business logic thing. It's just that's going to be a slippery slope. I mean, it's the same thing that happened with the enterprise service bus technologies over 15, 20 years, right? The challenge will be, when you need to make a change to some functionality, do I need to get 5 different teams in? And if I need to do that, then that's the wrong path.
Yeah, the service mesh should really be the common parts, not the special parts.
Exactly, right.
And I think the one thing not to do with service mesh is to rely on it as as an answer to all your problems, right? You still need a good distributed systems architecture. You still need to think about how your systems are laid out and how they're communicating, right? Don't expect it to solve all those problems for you, right? It's just that common layer, right? It's not solving your business problems.
Yeah, I think these are really good answers. Let's moving on. We got a question 51 from Herlan. How about resources overhead of Istio and Linkd, especially memory? When you have a big cluster, more than 100 nodes, and Spring Boot microservices, well, the memory is about 450 megabytes per each of the microservices.
For Spring Boot or for the proxy, or what is the memory? Spring Boot is going to be a lot higher than that.
Yeah, I think he was saying Spring Boot microservices where the memory is about 450. Is that reasonable for Spring Boot? For 450 megabytes for each one? I assume the user might
so one thing I would
Spring today, and they're looking at Istio or Linkd next, and think about what are the resources they need to plan.
Yeah, so I was just going to say 100 nodes is.
Go ahead.
100 nodes is not a big cluster. A big cluster is 5,000 nodes, 10,000 nodes. Right, those are big clusters. 100 nodes is small. If you're having problems with your current system at 100 nodes, then yeah, you need to switch to something that can scale. That goes to my point about things that can scale. That have been tested at large sizes. And the memory usage, so I can talk about Istio. Obviously, Oliver can talk about Linkd, but the memory usage for Istio is pretty minor, especially in the latest releases. Early releases of Istio had much larger memory footprints than they do now, but the latest, it's actually really small, especially at something like 100 nodes. I think we can run a single control plane instance can handle up to like 1,000 nodes or something. So yeah, you barely would notice that the proxy would be pretty.
Yeah, the benchmarks I've seen last, the Linkd proxy was running between 20 and 30 megs per sidecar. And Envoy, I think, is probably 100-ish in a similar use case. So there are, those are the benchmarks I've seen, so run your own for your application, please. But we've tried to make our proxy really lightweight and small, but that's just one data point.
Yeah, and people do need to realize, even with the small proxies, and I believe Linkd and Istio both have fairly small proxies, it's the number of pods you have in your system. I don't care how many nodes you have. How many pods do you have running that are part of that mesh? Because at the end of the day, it does add up. It will have an impact at some level. You're getting value.
Hey, Dan. Yeah, we lost you for maybe 5-10 seconds, Dan.
I guess I talk too fast. I was just going to say, it's really dependent upon the number of pods that you have at the end of the day, because even with a small incremental addition to the performance, the memory, it adds up over time. So you do have to account for it, even though it is still very nominal.
Okay, so I think we have, Oliver, you also answered the question too, right? We have Linkd perspective on this too?
Yep, we've got a tiny proxy, very small.
Okay.
Let me also just throw in, because it asked about the resource overhead of Istio and Linkd, but service meshes in general versus the alternative is an interesting point, right? Because especially for the Java folks who are on Spring Boot, their alternative is to use something inside the library, inside the framework. So Spring would be Spring Cloud, or in the past people have used the Netflix OSS stack. Bringing those things into the JVM and all their transitive dependencies and all the classes you load into class namespaces and all that stuff, that's actually, it ends up being more overhead to do that than run a service mesh proxy. And the point that I always make is, absolutely. But the point that I always make is you if you're going to run these large distributed systems in cloud infrastructure, for example, Kubernetes, you have to solve these problems around resilience, around security, around observability, and so forth. So it's not optional, really. You're going to have to pick the one that best suits the resource, constraints that you have, and putting it into the application may not be the the best choice. It might, but it might not.
Okay, great. I think this answer all indicate, the current leading service mesh in the market is a lot more lightweight than the memory required by the Spring Boot microservices today.
Yes.
Okay, let's moving on. We might be able to take like two more questions. Let's see. Question number 62 from Stefan. How do service meshes reduce latency?
I'll take this one if you don't mind.
Go for it.
Service meshes can reduce latency by load balancing. Load balancing is a great tool, and it can be very difficult to wire this into your application directly, although the gRPC world is definitely growing these things internally. But if you're talking to many pods, or you say you have 10 to 100 pods you're talking to, choosing the least loaded one is absolutely going to impact latency in a busy system. So great tool to use service mesh for.
Choosing the least loaded one, choosing the one that might be closer to you in terms of locality, trying to respond to a client when a request to one of the upstreams isn't returning, and then you might need to send out, a second request. So the mesh definitely does a lot of kind of application networking under the covers for you that can definitely improve your latency numbers.
The interesting thing about the points that you guys just raised, I was scanning through some of the questions, and one of the questions was, what's one of the gaps that a service mesh provides over and above Kubernetes itself? And one of the number one things for me is the load balancing. Anyone that's used kube proxy realizes that kube proxy is not really a load balancer at all. It's extremely dumb, has no logic. You can't control it. Whereas the service meshes give you a true client-side proxy load balancer that is programmable, different types of approaches for doing the load balancing, just like what was called out here. Huge advantage over what Kubernetes gives you in the box.
And to be clear, we're talking
Kubernetes
about
doesn't seem
we're talking about load balancing. We're talking about requests. We're talking about request level load balancing. So a certain HTTP request and its response taking this amount of time, where everything else in the Kubernetes ecosystem is just dealing with TCP connections, which is a really dumb way to do load balancing.
Yeah, exactly.
And it's perfectly fine, right? Because Kubernetes is there to deploy applications and scale them and check their health and so forth. Kubernetes isn't necessarily there to route a specific request to a specific pod because it has certain metadata or whatever.
Exactly.
Yep, each has its own purpose.
I'd like to add,
go ahead.
Can I real quick add two other ways that actually they reduce latency that we've seen with production users. So one is that actually the proxy implementations of these systems are often better than the native language if you're not using C++ natively. And so we've actually seen immediate latency increases just by having a better implementation of like HTTP2 or being able to upgrade to HTTP2. So the tunneling sometimes actually can improve latency. The other way is actually they will help you see where your latency bottlenecks are in your application and see where problems are occurring and actually help you reduce the overall latency of your system by finding those bottlenecks. So there's lots of different ways they help.
Yeah, that's really interesting. In fact, I think we saw people reports on Twitter that when they upgrade to service mesh, they actually find out their latency improved with mutual TLS and everything from the mesh. Okay, I think unfortunately we're running out of the time. I want to take a minute to thank all the panelists for answering questions today. Really appreciate it. Also keep in mind we do have KubeCon-service mesh where you guys can, answer, keep asking us questions for the next 15 minutes. We will be around. I have to apologize. There are just about 100 questions coming in and we couldn't answer most of them. So we will take the conversation over to Slack on the KubeCon Service Mesh channel. Thanks, everyone.
Thank you.
Thank you.
Thanks.